Welcome to another coding tutorial, and in today's video I'm going to show you how to create this colorful gradient spiral. This tutorial is my attempt to recreate a piece by Ahmad Musa, who you might know by his alias name Gorilla Sun, and he has an amazing blog and newsletter by the same name, which I take tons and tons of inspiration from. And he created this piece as part of last year's January, which is a month-long generative art challenge that takes place in January. And if you're looking for a fun and inspiring way to code alongside an amazing group of people, I encourage you to check out this challenge and also this year's 31 prompts, which have recently been released. Alright, I'm going to start by creating a grid, which I'm going to fill with the letter X. So how about we declare a few variables? Let's do columns, rows, and size. I'm going to set the size to be, how about 10? And then in size setup, we're going to calculate what columns and rows are going to be by dividing width by size and height by size. Alright, and then inside draw here, we're going to use a nested loop. So it's going to go from I equals to 0 to I less than columns, I plus plus, oops, and then j equals to 0, j less than rows, and then j plus plus. And then to draw or to write a text on the screen, we can use a built-in function called text, which takes in a total of 3 arguments. The first one is going to be the letter or the piece of text that we're going to write. I'm going to just write a letter X. And then the second and the third are going to be the X and Y coordinates of the bottom left corner of where the bounding box of the text is going to be. That's the default anchor point. So I'm going to declare X and Y here, and then we're going to set X to be equals to I times size, and then Y to be equals to J times size. And this will allow us to space out the X and Y location of each of the text evenly. Let's click run. Alright, so as you can see here, there is a bit of a gap here, right? The first thing that I want to do is I want to move the anchoring point from the bottom left corner of the bounding box to the middle of the bounding box. So what we can do is we can use a function called textAlign, and we can provide 1 or 2 arguments. Let's say we provide 1 center, and as you can see here, everything moved to the left. And that is because we moved the anchoring point now in the x-axis to be at the center. And I also actually want to do the same thing for the y-axis. So I'm going to provide the second argument center. And so now if I change this to, let's do actually 40. All right, so you can see that the anchoring point now is at the middle point of this letter X, right? But now we need to change the location of these X and Y. So we want to offset it by what? We want to offset it by size divided by 2 in both X and Y direction, such that now everything is centered on the screen. And how about we also set the new text size, and we can set it to be whatever we want, but I actually want to set it to be according to the size here. So let's try that. All right, and then now let's move it back to size of 10. Perfect. Next, we're going to be creating a spiral using these letter X. And the type of spiral that we're going to be creating is called an Archimedean spiral, which can be represented by this equation here. R equals to A plus B times theta. And I'm actually going to be changing the variable names a little bit, but let's look at this equation here. So R is the radial distance from the origin, and the origin in this case is actually the middle of the canvas. And the r, or the distance here, is going to be the distance measured between the x and y coordinate of the anchoring point to the middle of the canvas. And then theta is the angle in the polar coordinates, which measures the angle between the positive x-axis and the line segment connecting the origin to the point. And a is a constant that determines the spiral starting point. And then b is going to be the constant that determines the spacing between each turn of a spiral. We want to determine the path of the spiral so that we know where to draw the letter x. And as you can see from the equation, there are two main components. The first part is the radial or the distance component, how far it is from the center, and then the second component is the angle component. At what angular rotation does it match the spiral curve? Let's start by figuring out the distance between the anchor point, which is the middle point between each of these letter x, and the middle of the canvas. And we can actually use a built-in function called dist, which takes in the total of 4 arguments, which are going to be the x and y coordinates of the 2 points that we want to find the distance in between. So I'm going to declare this variable called d and set it to the built-in function dist, and we're going to put in x and y, which is this location here, and then width divided by 2, and then height divided by 2. And let's just start by working with the radial component. So if I write a conditional statement that says if d is greater than, let's say, let's actually use a variable called threshold, and how about we set threshold to, let's do 10. And then, so if it's greater than 10, then we want to draw x. Else, let's draw a dot at x and y location. All right, so you can see we can change the threshold here to be bigger. So if we only work with the radial component, you will just get basically a circle, right? We actually want to also put in a sine function which actually oscillates between -1 and 1, so that we can actually get this oscillating or periodic visualization. How about we set a variable called spiral path and set it to d right now, right? And we put spiral path here. Still the same, but if we put in sine, so sine of d will return a value between -1 and 1 instead of giving us just an on and off of whether it's more than a threshold or not. But because it only gives a value between -1 and 1 for the threshold, we need to change it. So how about we do 0.5? Whoa. What if we do 1? Okay, what if we do -1? Okay, so with 1 and 1, because that's the extreme case, it's either a dot, or an x, right? So maybe we do 0.5 here, but we can also play around with the values inside here, right? So what if we divide it by k, which k is going to be a factor of something, right? So let's do k equals to 100. Ooh, what if we do 10? All right, so now we get this oscillating circular bands, right? But it's still not a spiral. So what we actually need to do is that we need to incorporate the angle component, and we can do that actually quite easily by first calculating what the angle would be. An angle is basically the angle that is measured between the x-axis and the line that connects the origin point or the middle point to the x and y coordinates, right? And we can actually use a function called a tan 2 to do the inverse tangent to get the angle. And this is because a tan 2 takes into account the signs of the x and y coordinates that we put in as arguments here and return the angle in the right quadrant. And a tan 2 takes into arguments x and y, and actually it takes in y first and then x. And the x and y arguments that we want to put in here is actually the distance between the x and y anchoring point here and the middle of the canvas, right? And because we calculated the distance using this dist pre-built function here, we actually need to actually calculate what dx and dy is again, and is going to be x minus width divided by 2 for dx, and then dy is going to be y minus height divided by 2. We're going to put in dy and then dx here. And then inside the spiral path here, we just need to add angle. And hopefully we get a spiral. Yay! Perfect. So let's set t to be equal to 0. And we're going to add t here. And then how about we increment t by 0.01. Ta-da! And you can see that it moves in one way, and you can change this to negative, increment it in an opposite way. All right, so you can do whatever you like to get the kind of animation to your liking. All right, so now before we move forward to change the colors here, what about we play around with the conditions here? So actually, to get the piece that is similar to the one that Ahmad has, we need to play around with the condition here. We cannot just set it to a constant threshold of a certain number. Actually, I play around with it already, and what we need is, how about I set it as a new variable? Let's call it condition. And I'm going to set it to actually a very similar equation here. So let's do sine of d divided by, instead of just do, what if we just do k plus angle? Let's just do that and see what happens. Condition. Oh, yeah, you don't really see any changes. Let's see if I change this to 100. Oh, that's kind of cool. All right, but you don't see a lot of changes. But what if I change, let's create radial. No, let's do distance factor and set it to maybe, how about 100? And instead of k here, we're going to do distance factor. And then I'm going to do another factor. Let's call it angle factor. And I'm going to set it to 5, and then I'm going to multiply it to angle here, angle factor. Boop. All right. Let's try that. Ta-da! All right, I'm going to stop it from moving first. And you can kind of see that I think the factor here actually changes the number of these kind of like grouping of spiral shape, so you can play around. And how about if we change this to something smaller, 50? What does that do? So this is something that you can, work with, play around. But I'm going to keep it at 5 here and then 10 to get the shape that I want. And then uncomment this. All right, so now we are going to go to the last part, which is to give it some nice colors, some gradient color. So first, I'm actually going to modify the code a little bit. Actually, let's start by setting the background to be black. And instead of actually drawing text here, what I'm going to do is that I'm going to draw text outside. And we're going to draw this variable called symbol. And we're going to declare a symbol here. And we're going to set symbol as x if it satisfies the condition. But if not, then we're going to be drawing a dot. And then I want to also set color. So how about we also declare a variable called C for color. So C is going to be equals to a function that we're about to write. Let's call it color gradient. And it is going to actually be based on the distance t that we declare here. But if it's not part of the condition, let's set C to be the color white and maybe give it a transparency of 100. And then we want to fill in C here. And if I click run now, it's going to give me an error because we have not written this color gradient function yet. So let's do that. So function color gradient. And the parameter that we're going to put in is D. So we're going to start by, actually, instead of doing this, let me just put C to be a color. How about just red? So you can see that it still works. All right. And then now what we're going to do is we're going to start by declaring an array. And I want to have an array of 2 values. Let's start from there. And it's going to be 2 colors. So what color should it be? How about these colors? You see what they are in a little bit. And then I'm going to declare a new variable. Let's call it color radius. So this is basically going to determine how we break out this friend of these color bands. So I'm going to set it to 10, and then I'm going to calculate another variable called C, and C is going to be based on the distance and then the expression called modulo and then color radius. So let me explain how this thing works. The modulo expressions returns a remainder between 2 numbers, and it is very useful to use it to loop around a lot of stuff, and we have done that in a grid system in my previous tutorials, but in this one we want to use it to actually determine which band it is at. So what I mean by that is, let's say that we have, what do we have? We have color radiant, right? Let's set it to, how about 10? And then what if we have a distance of, let's do 11, right? And so if C is equals to D mod color radiant radius. Anyway, let's just do color R, and then let's print what C is. We get a value of 1, and that is because 11 divided by 10 goes into 11 one time and has a remainder of 1, right? But if D equals to 1, we get a remainder of 1. If D is equals to 10, then we get 0. And if D is 0, we get 0. That means that a value between 0 to 9, we get a return value of those numbers 0 to 9. And starting from 10 to 19, then we get values between 0 to 9 again, and so on and so on. And that's exactly what we want. So we can get a range of where it is, and it will never just keep going up and up and up, right? We get a loop between 0 and 9. But what we actually want to do next is we actually also want to divide it by color R, because I actually want a value between 0 and 1. So we will get a decimal point between 0 and 1. And we are going to do that right now. So we're going to divide it by color radius. And the reason that I want to do that is because we want to return a gradient of colors. So we're going to use a function called lerp color, and lerp color takes in a total of 3 arguments. The first 2 are going to be the color that we want to lerp, which is to do linear interpolation or to pick a color between 2 colors. So we're going to put in the first color, which is colors of 0. So this one here. And the second one is going to be colors of 1. And then the third argument is going to be the amount that we want to interpolate in between, which is going to be between a value of 0 and 1. And that's why we want to divide this expression here by color radius. And if I put C, actually let's do AMT for amount. And now what we can do is we can just call color gradient of D here, right? And let's see if we can get this gradient. Ta-da! Okay, we're gonna stop this. And because we just do 10, you can see that it just switches between the two colors multiple times. And if I do 100, then now you get a bigger band, right? How about I do 120? All right, and if I do, let's say 200, you probably just get like 1.5 band here. All right, I'm going to set it at 120 and return this back. All right, I think I actually want to end here. There's still a lot that you can play with, whether it be the condition here, also the colors. And right now inside the color gradient, I only use just 2 colors. I'm actually going to show you or put in the code here of how to do multiple colors, so you can check out the code in the description below. But here's my take on this. So be sure to check out the newsletter and also the January of 2025 31 prompts. So I hope that you'll like this one and give it a try.